All right, you're going to need your notes that we started on Friday. We're going to do some work on those. And also you're going to need periodic table, which is in your Google Classroom under references. And we use a periodic table a lot, so you'll need to be able to have quick access to that. If you have a chance, you might want to print it out. All right, does anybody remember the number on the periodic table that is above the symbol? Does anybody remember anything about that? What it's called or what it represents?
The atomic number?
Yes, that's called the atomic number. And does anybody remember what it represents? Talking about our subatomic particles?
Number of protons?
Yes, exactly. It represents the number of protons. And then the number below, anybody remember what that or what that's called?
The mass?
Yes, it's called the atomic mass. Exactly. And if you round it, you don't need to write this part down in your journal. If you round it to the closest whole number, then it can be used for the mass number. But in general, just like it is, it's the atomic mass. And we're going to learn how to calculate that actually tomorrow. You have 3 quizzes this week. You'll have tomorrow, you'll have one over atomic history. So you need to study your notes. We did a little bit of notes, and then also the notes that were in your Google Classroom that you used to fill out that paper. For those of y'all that did fill out the paper, some of y'all didn't do the assignment. And also then Wednesday, subatomic particles, which is what we're doing today, and Friday, average atomic mass. I have tutorials on Tuesday, Wednesdays, and Thursday. Remember, if you're going to come to tutorials, since y'all are virtual, I need you to let me know at least an hour before they begin, so I'll know that I need to open up that link. And then last day to re-quiz, these dates are listed right here. Because remember, if you fail a quiz, you can retake it and try to bring it up to 70, but that time is not unlimited. So for instance, if you fail the quiz tomorrow, which hopefully you won't since it's just 10 multiple choice questions, but if you do, then you have until Thursday to come into for tutorials and re-quiz on that one and try to bring that grade up. All right, so if you'll go to your notes. I think we were right here on our notes. So atom, smallest particle of an element that keeps the chemical properties of that element. And it contains the two regions, the nucleus and the electron cloud, which we talked about those on Friday. Also, the nucleus has your protons and your neutrons. And that's where the mass of the atom is. And then the electron cloud obviously has your electrons. So that would be where the volume is. And I kind of mentioned that a couple of times already in our notes that we did on Friday. So that's pretty important. So going through our different subatomic particles, the first one is a proton. And it's located in the nucleus. The number of protons stays the same. under ordinary chemical reactions. If it undergoes a nuclear reaction, that may change, but just under ordinary chemical reaction, it would stay the same. You can see the symbol, the charge, the mass is 1 AMU, which stands for atomic mass units. You can see it's very, very small, 1.67 times 10 to the negative 24 grams. But even though it's that small, it's still about 2,000 times greater than or larger than the electron. So proton and neutron are about equal to each other in size and mass, but they're much, much larger than the electron. Your protons are represented by the atomic number. And your atomic number identifies an element because it doesn't change. Your atomic mass or your mass number may change, but atomic number does not change. The next subatomic particle would be your neutrons, also located in the nucleus. Neutrons can change in an element. We'll call those isotopes. We'll talk about those a little bit more in a little bit. Neutrons stabilize the nucleus by nuclear forces, and nuclear forces are forces that act over a really small distance. And it can be between neutron-neutron, proton-neutron, or proton-proton. I don't have an opposite. I don't have a plus and a minus for them to interact or to attract each other that way. So there has to be another force that's keeping them together in the nucleus. It's called a nuclear force. You have your symbol, your charge, and like we said, it's 1 AMU, about the same as a proton. The number of neutrons can change, and we call those isotopes, which are atoms of elements with different number of neutrons. And since they would have a different number of neutrons, they're going to end up having a different mass number. All the elements in the periodic table have at least one isotope, and some of them may have up to 25. And then our last subatomic particle would be our electron, found in the electron cloud. The number of electrons can vary. And when that happens, then an ion is formed. Electrons are responsible for the chemical reactivity because they are what end up being involved in the bonds, and specifically the valence electrons. It says that the number of electrons can change, and that's because atoms are neutral. Atoms, everything on the periodic table, but if an atom loses or gains electrons, it'll form an ion. And that is done sometimes because it increases the stability. So the nucleus contains most of the mass, and the electron cloud contains most of the volume. All right, isotopes, we talked about those. I've mentioned them a couple times, are atoms with the same number of protons, because that doesn't change, but different number of neutrons, so that will make the mass number change. If you remember back from junior high, mass number is equal to your protons plus your neutrons. So if I change my neutrons like we do in isotopes, then that in turn is going to change your mass number. Usually isotopes are referred to by their name or symbol and their mass number. Now, every element has at least 2 isotopes and some up to 25. So if I have carbon 12 or C, because that's the symbol for carbon, C12, that 12 is equal to the mass number. I don't have to put the atomic number on that notation because the atomic number can always be found on the periodic table. It does not change. If the mass number is not given, use the atomic number, which is on the periodic table, and round to the closest whole number. So as we start working through these, sometimes you'll be given the mass number, but sometimes you'll have to use that atomic mass and round it to a whole number to get your mass number. All right, we're going to look at some notations. So this is a real typical notation, what you see right here. It's called chemical or nuclear because it tells you what's in the nucleus. The smaller number is always going to be the atomic number. The larger number will always be your mass number if you have 2 numbers. Like I said, if you just have 1 number, so here sodium 23 or maybe Na 23, if you just have 1 number given, then that's going to be the mass number because I can always get the atomic number off the periodic table. Remember, symbol is what's called kind of the abbreviation, although it doesn't always seem to go with the name of the element. Atomic number is always going to be your smaller, mass number always your larger. Atomic number is represented by Z and mass number is represented by A. Not really for sure where those came from. So the atomic number Z is the number of protons in the nucleus. And like I said, that identifies the element because it does not change. Because the atoms are neutral, they're going to contain the same number of electrons as they do protons. Mass number, on the other hand, is the total number of protons and neutrons in the atom's nucleus. Wednesday.
Oh, is that?
Yeah.
Okay.
They come back Wednesday.
This morning, but
Yeah, some of them come back Wednesday. Okay. All right. So isotopes, we can look at these of hydrogen. Hydrogen has 3 isotopes that are very common. They're so common that they actually have their own name. Isotope is element number 1 on the periodic table. So that means it has 1 proton. So you can see these 3 isotopes, protonium, deuterium, or tritium. They all have one proton because we said the proton doesn't change. They're neutral, so they all have one electron, but you can see what's changing is the number of neutrons. That's what changes within an isotope. And because that changes, that's going to cause also the mass number to change. So my first one would have a mass number of 2. My second isotope, mass number of, try that again. 1 plus 0 would be 1. My second one would have a mass number of 2. 1 plus 1 would give me 2. And my last one would have a mass number of 3. 1 plus 2 would give me 3. And once again, those mass numbers are different because, not because the protons has changed, but because the neutrons have changed. If I was going to write notation for those different isotopes, they would be H1, H2, and H3, because that represents the mass number. All right, we're looking at a little bit of practice here, and then we're going to talk about some ions. And I know y'all have done this before in 8th grade, I believe, 7th or 8th grade, I think 8th grade. All right, so if you're trying to figure out subatomic particles, they're all related to each other, so you kind of just need one thing and a periodic table to get you started. If you like a mnemonic, Ape Man may help you with this. Ape, atomic equals proton plus neutrons. Atomic equals protons and electrons. So if you know your atomic number, you're going to know your number of protons and your number of electrons. Mass number minus your atomic number will give you your neutrons. So like I said, they're all related. So we'll start with uranium, and we're going to figure out how many protons, how many neutrons, and how many electrons. So uranium is a radioactive element. So it's in those two little pulled out sections at the bottom of your periodic table. And it has an atomic number of 92. So that means it has 92 protons and 92 electrons. And then to get the neutrons, I'm going to take the mass number, subtract the atomic number, and that will give me my number of neutrons. All right, I'm going to pause for a minute and let y'all try those other 3, carbon 14, potassium 39, and sodium 23. And like I said, you'll need your periodic table for this, which is down in references.